Okay, in this first example, we are going to have two lines in 3D. L1 is defined via a parametric system of equations. L2 is defined by a symmetric system of equations. Now, in part A, we want to find the vector form of each of the lines. In part B, we want to determine if P1 and P2 lie on L1. In part C, we want to find the normal distance, that means the shortest distance from L1 to this point here. In part D, we want to find the angle and the point of intersection between L1 and L2. So let's get on with the first question. We want to find the vector form of the equation of L1, which is given in parametric form. So there is L1. So what we need to do is to find remember the vector form of the equation of straight line is this one here, MT. So we need to find a point on the straight line, and then we need to find the direction vector. That's all. Okay. The point on the straight line we can find by simply setting the parameter t to be any real value. Okay, the easiest one obviously is t equals to 0. So if t equals to 0, then x is going to be 3, y is going to be 9, and z is going to be 13. So that's going to provide us with the R0, the position vector of this. Notice that obviously this is going to be unique. Somebody else can choose t to be 1, in which case their x is going to be 4, their y is going to be 14, their z is going to be 18. That is equally correct. So then the next thing is the direction vector. So the direction vector will simply be the coefficients of the parameter t for each of the equations, because you can see that it's m times t here. So for the first equation, coefficient of t is 1. For the second equation, coefficient of t is 5. For the third equation, coefficient of t is 5. So that means the vector form of this equation is going to be 3, 9, 13 plus t into 1, 5, 5. Because we could write this in column vector formulation. So that's going to be the vector equation for L1. Then next to L2, whose equation is given in symmetric form. Okay, so for this one we are going to have to first get the so this didn't work. This is still the equation for L1. So now we want this one here. Okay. And there you go. Okay, so what we are going to need to do is to equate each of these to some parameter. I'm going to use lambda. Then from the first one we get x. So basically we need to derive the parametric formulation of the equation. So x is going to be 7 plus 2 lambda. Y is going to be 2 plus lambda. Z is going to be minus 6 minus 3 lambda. Okay, then from what we did above, the constants are just going to give us the position vector of the point on the line. It'll be 7, 2 minus 6, and then the coefficients of lambda give us the direction vector 2, 1 minus 3. Okay, so that sorts out question A. Question B, we want to determine if 4 minus 2, 7 is on the line L1. So B, want to check 4 minus, what is it, 4 minus 2, 7. And then I'm going to bring back the equation for L1. So this one here. So that's the equation for L1. So we need to check if this point satisfies this system of equations. Okay, so there's 3 of them. So what I'm going to do is I'm just going to take 4 and plug it in here and solve for t. So 4 is 3 plus t. Then if I solve this, it gives me t is negative 1. So now next, if I plug in negative 1 here and here, if this point is on this line L1, must give me these 2 respective values. So let's see. If I plug in t is negative 1 here, it gives me 4. Okay, so this implies that y is equals to 4, and straight away it is not equal to that, and so we can conclude that P1 is not on the line L1. Okay, then go to P2. P2 is 248. P2 is 248. Okay, so if we do the same thing, this time we're going to have 2 is equals to 3 plus t here. And so t is minus 1. Did I do something? Oh yeah, there was a problem with this one. So let's go back because I don't get minus 1 again. This is actually t is negative 1. So let's see, if you plug in 1 here, this is giving us y is 14, not 4. Is y 14 here? No, it isn't. So we still arrive at the same conclusion but not coincidentally, okay, through the correct steps. So this one gives now t is -1. So if you plug in -1 here, it gives us y equals to 4, which agrees with that. Plug in -1 in this equation. 13 minus 5 was 13 minus 5 is 8, which agrees with that. So we can conclude that P2 is on the line L1. Okay, so that's our example number B. Example number C, I want to find the normal distance from L1 to this point here. So just so from L1 to this point, this is example number C. Just put this point there. Nope. Let's put it here. Okay, and then let's bring back the equations for L1. There are the equations for L1. Okay. We are going to do two methods of this. So here is a graphical situation. So this is L1. We've got a point on L1. We say the point is 3, 9, 13 from these numbers here. And then the direction vector for L1 is M1 is 1, 5, 5, and then want the shortest distance from this point to L1. So it's 21 minus 5, 3. Let's put 21 minus 5, 3 here. 21 minus 5, 3. Okay. Now, in the first method, we want to call this dot product method. We are going to say there is a point on this line. Let's call its coordinates x, y, z. That point is such that this angle is 90. Okay. Then we're going to formulate a vector. So let's say this vector is going this way. So V is going to be x minus 21, y plus 5, z minus 3. However, this vector must be perpendicular to M, okay, which is the direction vector of the straight line. Okay. So that is going to give us an equation. So m dot v must be equal to 0. M dot v is going to be 1 times this, which is x minus 21. It's going to be 5 times this, which is going to be 5y plus 5, and then also 5 times z, 5z minus 3. This must be 0, so x minus 21 plus 5y plus 25 plus 5z minus 15, this must be equal to 0. If I take the constants to the right hand side, 5z, they're going to be 15 plus 21 minus 25. 15 plus 21 minus 25. It's going to be 11 this side. However, x, y, and z satisfy L1. So that means we can write x, y, and z in terms of t. X is 3 plus t, so we're going to have 3 plus t here. Y is 9 plus 5t. 9 plus 5t. Z is 13. Is it 13 plus 5t? Equals to 11. So this is going to give us t here. 5 and 5 is 25t. 5 and 5 is 25t. If you take the constants to the other side, it's going to give us 102. This is 51t. Is negative 102, so t is negative 2. So once we got t, then we can write v, because okay, so let's just do this. When t is negative 2, okay, maybe let's do this. So v is x minus 21, but x is 3 plus t, so 3 plus t minus 21. Y is, well, the y coordinate of v is y plus 5, but y is 9 plus 5t, so 9 plus 5t plus 5, and then z in the vector v is z minus 3, so it's going to be this thing here minus 3, which is 10 plus 5t, so 10 plus 5t. Then if we plug in, t is 2. This is going to be 5 minus 21. 5 minus 21 is what is 5 minus 21? No, it won't be 5 minus 21. t is negative 2 here. So it's 3 minus 2, which is 1. 1 minus 21 is minus 20. Okay, this is negative 10. 9 minus 10 is minus 1. So it's going to be 4. T is negative 2 here, so it's going to give us 0. So this has got a common factor of 4, so we can write it as 4 into the vector minus 5, 1, 0. The smallest distance, by the way, is just the magnitude of v. So so rho is going to be the magnitude of v. This is going to be 4 into square root 26, where 26 is given by 5 squared plus 1 squared. So that's going to be the shortest distance from L1 to that point. There is another method which is called the parallelogram method. So parallelogram method. Okay, so what we do this time, so this is L1. On L1 we know we've got a point, and the point is 3, 9, 13. Okay, then we have got the direction vector, which is m. So imagine this side is m. M is 1, 5, 5. Then if we put the point of interest here, the point of interest is 21 minus 5, 13. 21 minus 5, 13. Then we are going to form a parallelogram. Okay, we're going to form a parallelogram. One of the vertices is going to be 21 minus 5, 13. If I'm remembering it correctly, no, it's 5 minus 5, 3 actually. 21 minus 5, 3. This side is going to be m, the direction vector, this side here. Okay, then this vector, let's call it W. So we already have one side of the parallelogram. We're going to have this other side as the vector joining these 2 points. So W is going to be 21 minus 3 is 18, minus 5 minus 9 is minus 14, 3 minus 13 is minus 10. Now here is the point. We know that the area of this parallelogram is the magnitude of W cross M. Okay, so the area is going to be W cross M, then we take the magnitude of that. But also from formulas from high school, we know that the area of a parallelogram is simply the base, which we're going to take to be m, times the height. The height is the vertical distance from our point of interest to the straight line. Okay. So this must be equal to, the base is going to be the magnitude of m, and then the height is the perpendicular distance or the normal distance we're looking for. We can work this out, so we can find rho. Okay. So let's start by working this one out. So W cross M so we're going to plug in W here. So that's going to be, where's W there? It's going to be 18 minus 14 minus 10. M is 155. Okay. So the first one is going to be minus 14 times 5 plus 50. So minus 14 times 5 plus 50. That's going to be minus 20. And the second one is going to be minus 10 minus 18 times 5. So minus 10 minus 18 times 5. I'm going to give us minus 100. Minus 100. Then the last one is going to be 18 times 5 plus 14. So 18 times 5 plus 14 is going to be 104 positive. 104. Okay, then the magnitude of this, so we take the magnitude of this, but before we do that, we notice that 4 is the common factor of these numbers. So we factor out 4, it's going to be minus 5, minus 25, and there's going to be 26. So the magnitude of W cross M is going to be 4 into 25 plus 25 squared plus 26 squared. Okay. And then the magnitude of M is 155. So it's 1 plus 25 plus 25. That's square root 51. So from here, then rho is going to be 4 times so 25 plus 25 squared plus 26 squared, 1326. Divided by square root 51. Well, what is 1326 divided by 51? That's 26. So that is going to be 4 square root 26 as found before. The last part of the question, which is D, wants us to find the angle between the two lines, which we already did in a previous video, but also wants to find a point between L1 and L2. We're going to do this in the next video.